Agriculture is both a significant contributor to climate change and one of the most vulnerable sectors affected by it. This dual relationship underscores the need for a robust understanding of climate-agriculture interactions, mitigation strategies, and adaptation measures. Module 8 delves into the biophysical feedback loops, GHG emissions from farming, climate vulnerability, and resilience planning in agricultural systems. It also covers technological, ecological, socio-economic, and policy-driven solutions for climate-smart agriculture, CSA. This module goes beyond theoretical concepts by embedding critical case studies, empirical research findings, and integrated models like DSSAT, APSIM, and GLEAM. Special attention is given to international frameworks such as the UNFCCC, IPCC, Paris Agreement, and Koronivia Joint Work on Agriculture, all of which shape global mitigation and adaptation agendas. The module also addresses the intersectionality of food security, climate justice, rural livelihoods, and the ethical responsibilities of developed versus developing nations in carbon reduction and sustainable food system transitions. By the end of this module, you should be able to 1. Identify and explain major greenhouse gas, GHG, emissions from agriculture. 2. Analyze climate-induced risks and impacts on crop, livestock, forestry, and fisheries sectors. 3. Evaluate feedback loops between agriculture and global warming processes. 4. Apply adaptive strategies in different agro-ecological zones. 5. Explore the role of technology, traditional knowledge, and global policy in climate adaptation. 6. Design mitigation projects using carbon accounting and emissions inventories. Agriculture as a driver of climate change. Agricultural activities contribute approximately 20 to 25% of global greenhouse gas emissions, including carbon dioxide, CO2, from deforestation and land use changes, methane, CH4, from enteric fermentation in ruminants, manure, and rice paddies, nitrous oxide, N2O, from fertilizer use and nitrification-denitrification cycles, black carbon and aerosols from biomass burning, emission hotspots, industrial agriculture in developed nations, and forest clearing in tropical zones. Climate change effects on agricultural systems. Crops. Shifting rainfall patterns affect planting and harvesting calendars. Heat waves reduce grain filling and pollination in sensitive crops, e.g. maize, wheat. Increased CO2 fertilization may benefit C3 crops but lead to nutrient dilution. Livestock. Reduced feed availability and water stress. Increased incidence of heat stress and diseases like tick fever. Impacts on reproduction, milk yield, meat quality. Fisheries and aquaculture. Ocean acidification, coral bleaching, altered fish migration. Salinity intrusion in coastal zones affects shrimp farms and rice paddies. Forestry. Increased pest outbreaks, fires and droughts weaken carbon sinks. Feedback loops and tipping points. Positive feedback, melting permafrost, methane release, global warming, land degradation, overgrazing, soil carbon loss, reduced resilience, more emissions, albedo effect, deforestation reduces reflectivity, accelerating warming, desertification cycles, degraded drylands become climate hotspots. Adaptation strategies in agriculture. Crop diversification and use of drought-tolerant and heat-resistant varieties. Agroforestry, integrated farming, and conservation agriculture. Rainwater harvesting, solar irrigation, and mulching to retain soil moisture. Climate Information Services, CIS, for weather forecasting and early warning. Indigenous knowledge in dryland farming, e.g. Zai pits in the Sahel. Mitigation approaches in agriculture. Climate-smart agriculture, CSA, integrates productivity, adaptation, and mitigation. Carbon sequestration, biochar, reduced tillage, afforestation, and soil management. Manure management, biogas systems, composting, and anaerobic digesters. Alternative wetting and drying, AWD, in rice cultivation. Nitrogen use efficiency, urea deep placement, UDP, nitrification inhibitors. Technologie tools and decision support systems. SAT and APSIM for simulating crop limits interactions. Ye inventory tools, epicudzelines exact, befui an cool farm tool. Remote sensing, zetting bumas hangis drought and evapotranspiration. Precision agricultura, minimizing inputs, optimizing yields, and reducing emissions. Climate governance and policy instruments. United Nations Framework, Convention on Climate Change and Intergovernmental Panel on Climate Change reports guide adaptation finance and mitigation goals. Paris Agreement, 2015. NDCs, Transparency, Global Stocktakes. Koronivia Joint Work on Agriculture, KJWA. Recognizes agriculture in climate solutions, REDD+, reducing emissions from deforestation and forest degradation. National Adaptation Plans, NAPs, and Climate Resilience Strategies in Agriculture. Case studies. India's PMKUSUM scheme promotes solar-powered irrigation. Kenya's climate-smart villages, farmer field schools for resilience building. Brazil's low-carbon agriculture, ABC, plan integrates community-supported agriculture into mainstream production. Bangladesh's floating gardens, adaptive innovation in flood-prone zones. Ethiopia's Productive Safety Net Program, PSNP, combines food aid with climate adaptation. Climate justice and equity in agriculture. Vulnerable smallholder farmers bear disproportionate climate risks. Ethical debate. Should low-income farmers mitigate, or is it the duty of high-emitting nations? Women, indigenous groups, and youth as key actors in climate adaptation. Financing mechanisms, Green Climate Fund, GCF, Adaptation Fund, Loss and Damage Framework.